We shall now discuss about mean, that is also called the expectation and variance of continuous probability distribution. So here in this case, let's suppose that x as the continuous random variable, then we have to see that how we find Vx and also Vx, that is variance of the distribution. So for discrete probability distribution, you have seen that expectation of x equals to summation of x and px, provided that summation of px is 1, that is the total probability is 1. So in order to say x as the random variable, there must be total probability 1. So if summation of px is 1, in that case x is random variable, that is discrete random variable in this case. But what happened when it is continuous distribution case? So in continuous distribution case, summation sign will change into sign of integration. So here we in the discrete case, we sum this term one by one individually and distinctly. But here, your when you draw a graph for any continuous function, your graph will be something like this, and then you have to integrate this graph under some given limit of x, for example a and b. So therefore in continuous case, instead of adding them individually, you have to integrate the area that has been covered by this function. So we replace summation by sign of integration if we are dealing with the continuous random variable, and then we have x over here, and in place of px we have to write fx dx. So here px is the probability function or probability mass function when we consider x as a discrete random variable, but here this fx will be the probability density function. So when there is probability function mentioned for continuous distribution, and in that case we call that probability function as probability density function. In the integration, you have to integrate the given term for given range of value of x. So x belongs to R, means here R is the real number. That means it can be like from lower limit a to upper limit b. So in general, we can write x belongs to R. Similar thing you can do here, like instead of writing sign of summation, we can use sign of integration. X belongs to R, and x times fx dx, provided that total probability x belongs to R for the integration. So total probability fx dx equals to 1. So this is total probability. And now we have to understand that mean is denoted by mu, and also this is expectation of x, and expectation of x formula has now become like this. So this is the formula for expectation of x. Now let's talk about this variance sigma square. So in order to talk about the variance, so you know that from the discrete case, that variance of x is expectation of x square minus mu square, and then expectation of x square if you write in the probability and in the summation form, and then it will be summation of x square p x, and then mu square remains as it is. So mu square we can find by using the same formula here, mu equal to summation of x px if this is discrete random variable. If x is the continuous random variable, we can find mu by using sign of integration. So here in this case, as we have learned for the discrete probability distribution, now we are learning the continuous probability distribution. Therefore, what happens if you suppose x as continuous random variable, then this summation will become sign of integration, then x square, and this px will become fx dx, and then it remains mu square. Now in this case, this is for the continuous probability distribution, and you can write x belongs to R in order to say that the range of values of x in the integration. So in general, the lower limit can be m and upper limit can be n. M and n are any numbers. So here in this case, what you can write actually, expectation of x squared minus mu squared. Can also write in place of mu squared. For example, it is mu squared, then mu itself is expectation of x, so it will be expectation of x squared. Therefore, you can also write variance of x as expectation of x squared minus expectation of x whole square. All right. So in this case, I am dealing with now variance of x in general is expectation of x squared minus mu squared. And in expectation of x squared, you can write sign of integration, and then x belongs to the real number, and then it is x squared. We write here x squared. Then for px, we can write here fx dx, and then minus mu squared. Here the mu squared is for continuous random variable. So in this way, our formula for the variance as well as for expectation of x in case of continuous probability distribution have been ready now. So you have to now remember these two formulas. If you are going to find expectation of x, you have to use this formula, and when you are going to find variance, then you have to use this formula. Here are some examples you can see. This example says that the continuous random variable t has PDF given by ft equal to this. So you can see that this is in the form of some reciprocal function with a constant contained with this function and 0 otherwise. So first of all, let's draw the graph of this function in order to understand what is it, what it is mathematically and what it is statistically. So if I draw the graph, for example, and then it is 0, and then it is 1, 2, and it will go on and on up to positive infinity, and here 1, 2, it will go on and on up to positive infinity. Here to the left side it will be negative infinity, to the downside it will again be negative infinity for the y-axis, and here this is x-axis. So what I consider my function is here k by t square, that is y equal to k by t to the power 4. So in this case, if I keep on plugging in value of t, it starts from 1, and if you keep on going on and on, so as you increase the value of t over here, so this is k equal to t to the power 4, then what happens, as you increase this value, the whole thing will keep on decreasing. So as value of t increases, it goes, the curve will go near and near to the x-axis. That means it is showing the asymptotic nature of curve about x-axis. Now when you keep on decreasing the value of x from, for example, x equal to 2, and if you go towards left this way, then as you decrease the value of t, then value of y will keep on increasing and increasing, and then it will go near and near to the y-axis, but it never touches that y-axis. So at this part, it will show the asymptotic nature about the y-axis. Now what happens when you put the negative value for t? So even if you put negative values for t, and t is along the x-axis, your whole value will remain positive because of this even power of the variable t. So if I am going this way and I am writing that it is negative 1, negative 2, and I will go to the lowest and lowest value in the negative sense, then what happens, as you decrease the value of t in the negative sense, then it will go near and near to the x-axis, but it never touches the x-axis. And the similar work, from left to right, if you go here, it will go near and near to the y-axis, but it will never touch the y-axis. That means from left side also it will show the asymptotic nature mathematically about y-axis and also about x-axis. All right. And now, so this is the mathematical pattern of the graph for y equals to k to the power k divided by t to the power 4. Now, how is it statistically? If you can see here, this is ft equals to k divided by t to the power 4, and this is defined for t is greater or equal to 1 only. That means statistically, if you talk about the curve, so that curve is of only this part, not the any part left of this number 1 on the x-axis. So it said that k by t square for t is bigger or equal to 1. For rest of the thing, for example, for less than t, if you say, there is mathematically the part of curve here and here also, but that will not be considered. That means probability doesn't exist, or the probability hasn't been defined for other range of value for t. So therefore, mathematically the whole part is the curve, but statistically we can consider the curve from x equals to 1 to x equals to infinity. All right. So I hope you understood the difference between mathematical meaning and the statistical meaning of the graph. Now next, it says that so that k equals to 3. That means how can you show that k equal to 3 means, you know that as statistically the curve defines from actually x equals to 1, then total probability, if you find the area under the curve from 1 x equal to 1 to infinity, that will give you the total area, and that total area under curve will be the total probability for this distribution. And as t is the random variable, therefore the total area under this curve, that is the total probability, will be always 1. So we'll use that sort of properties of probability in order to find the value of k. So here you can see that we know that total probability is 1, and total probability is given as, that is, x belongs to R fx dx equals to 1. In discrete case, just like you used to write summation of px equals to 1, here we write integration sign in place of summation, and in place of px we write fx dx. And if you integrate the given curve in the entirely defined area as per it is given, and then that will give you the total probability. After that, you can see that fx, so here in this case, in place of x it has been used t over here, so you replace x by t. That means first of all the value range of value of t is 1 to infinity, and fx, that is here it is ft. So ft is k divided by t to the power 4, and so we write k divided by t to the power 4, and in place of dx we write dt equals to 1 in order to find the value of k. Now after this step, just integrate this. So note that you will require sound knowledge of integration, all right, before you deal with the problem with continuous probability distribution. This is most important to understand that how to integrate different kind of functions. So after this step, I can see here that k is constant, so you can take k outside, and then this is 1 to infinity, and if you break this reciprocal, then you can write 2 to the power 4, and then this is dt equal to 1, so it is k by minus 3, 1 by infinity is 0, and this is minus 1 equals to 1. Now this negative sign and another negative sign, when they multiplied, that will be positive. That means we are left with k divided by 3 equal to 1, and therefore it is k equal to 3. And it says that to show that k equal to 3, hence true. Now in the same question, you can see that the question is asking you to find expectation of t, that is mean of this distribution. That is, you have to find mu or expectation or mean of this function. So here in this case, you have to find the expectation of that function or that distribution. So you can see in question number 2 here, you have to find expectation of t. So here expectation of t equals to x belongs to R, or here as t is the random variable in place of x, so you can write here t belongs to R. Then in place of x you can write t, and then in place of fx you can write ft, and then dt. And after that, you have in this graph you can see that t starts from 1 greater equal to 1 means this t is from 1 to infinity. So in the range, we can write this is 1 to infinity, and t is here, and ft is k by t4, so we can write ft as k by t4, t to the power 4, and then this is dt. So now it is negative 3 by 2, and then you can write that again in the reciprocal form, so it is t square, and then it is 1 to infinity. Now just take these limits in this variable, in this result, so it is negative 3 by 2, and then you can write 1 by infinity square, then minus 1 by 1 square, because one time you have to put the upper limit for this variable and another time you have to put lower limit, and in between them there is negative sign. Now we are left with minus 3 by 2 and 1 by infinity, so this infinity square, so 1 is infinity square is still infinity, so 1 by infinity is 0, and then this is minus 1, so our expected value is this negative times negative is positive, so it is 3 by 2 times 1 is 3 by 2, so expectation of this continuous probability distribution is 3 by 2, or you can also say that expectation of the continuous random variable in this case is 3 by 2. After that, the question talks about also to find variance of that distribution. So variance Vt means this is the third part of this example, and variance, you can see that you know that variance of x equals to expectation of x square minus mu square, so this is our mu. All right, so mu already calculated, so we should now try to calculate this, but here in this case the random variable is given as t, so we write vt equals to e x t square. You can use capital letter also, it doesn't matter here, or a small letter, and this is mu square. And you know that if this is t square, then it is t belongs to r, that means we will integrate this function in the range of value of t, in this case instead of x, because variable is given in terms of t. And so it is t square, then ft dt minus mu square, means you can put the same value, so this is 3 by 2 square. So let's proceed further. So here first of all we'll try to find this value, and then finally we substitute back in order to calculate the variance of t. So this function is t belongs to r, t square ft dt. So we shall work with this only for some time, and then we substitute back that what we have got from here. So here it is range of value of t. In this case we have seen it just now that it is t is greater or equal to 1, that means it is from 1 to infinity, and this is t square, and ft is k by t4, and we know that value of k is 3 now, so it is 3 divided by t to the power 4, and then this is dt equal to, just simplify it first, and then it is minus 3 times, and 1 by infinity is 0, and 1 divided by 1 is 1, so negative time negative is positive, so your answer is 3. No, not the answer is 3, that expectation of t square is 3 in this case. So therefore your variance value, that is therefore vt, so vt is going to be equals to, for this we can replace, we have just now calculated this et square, and then it is 3, and then it is already here 3 by 2 square. Now let's calculate it. So it is 3 minus 3 3 are 9, and 2 2 are 4, it is 12 minus 9 divided by 4, and then this is 3 by 4. So this is the variance of this continuous probability distribution.